6 years ago, my third son was just born, and at the same time, across the ocean, one of the top language designer and a beloved person to all of us, I think, was talking about something that changed the way I look at coding and programming, and especially doing open source, but also working in the day job. And he said this thing that kind of uncovered something that I always felt inside, and especially since the first time I met Ruby. And so this is my third son, and this is that conference. And there's one thing that if you take one thing from this presentation, I'd like to be this. And I hope I'll share this message with you in a comprehensible way, in a way that you can have this new approach, this new eyes, and renew a joy while programming with Ruby. So, what about Ruby? That's I think that's the reason we are all here, and maybe some of us are working with this language, have worked with this language for many years, and of course, as Nick said before, you can encounter some frustration along the years, and you face some problems, and it's not always everything hunky-dory, but we are sticking with this language, and I think there's a reason. There is a reason. Why not we're going back to some other language? And also, why it is that this language brought in the programming world so many new things, and generated a community that is so creative. And we know that Elixir, for example, is heavily inspired by Ruby. The same goes for example, Swift, and even some of the older programming languages are catching up. I think PHP, Java, they're all adding stuff that mimics some of the features that came with Ruby. And we also know that there's a bunch of frameworks that just imitated the Rails, not necessarily in the technical part, but in the approach. So code generation and making things easier. So why Ruby? Here's a bunch of possible reasons, and I think they're all true. It's just beautiful. You go right to the point. If you have a well-written Ruby program, it's great to see. Not just to read, but you just see it, and you feel this spark of joy to quote. Yeah. So we have so many features. We have freedom, as DHH in a wonderful talk about this topic said. It's called Why Ruby. I encourage you to go and watch it. The thing he liked most about Ruby was this freedom, to the point that he wanted to rename monkey patching to freedom patching, to just remove this kind of bad marketing coming from the externalities. So, what is this one thing that I was mentioning? In that presentation, as I said 6 years ago, Mats was delivering this talk in which he was explaining Ruby as this kind of fantasy world. And to me, I would say this is also our everyday world, because we're in this room, and I think no one is thinking about the roof or the ceiling. We all trust that it works, it was done in the right way. No one is fearing it's going to collapse from moment to moment. And the same experience we have with Ruby. A great amount of work has been infused into this language and into the gems we use every day. We saw some great examples today. And as a bunch of work from many people that is all directed toward making our life easier. So the point that Matt made was that we are standing on the shoulders of not giants, but garbage collectors. So this thing I liked very much about what Matt said, because he didn't put himself like at the top. I'm the boss, I'm the language designer, the most intelligent and clever person in the community. No, he put himself at the lowest place. He thought about this work he's doing as a humble service to everyone else. And that I think is in line with the fact that we get each new Ruby release at Christmas. So it's a present from Mats that we get for free with much care for us. And you know, when you enter a room that has been beautifully prepared by someone, it's clean, everything is in order, you get some flowers on the table, I don't know, something like that. You get in the room and you immediately experience this kind of joy. You feel loved by someone. So that presentation made this clear to me at the time. And I think that's something we should all be grateful for. I'm so happy. As I said, we can talk, of course, about things that can be improved, but this is fundamentally a great thing about this language. And let's say it's also the reason why I care so much about this language, to the point that I started to search at some point around like 7 years ago, maybe, an implementation, a JavaScript implementation for this language. Because I thought, at the time, it was before that presentation, it wasn't clear to me. I was just looking as a way, I was just looking for a way to use Ruby even on the front end, because I was frustrated with JavaScript. I think everyone has seen some of the WAT presentations about JavaScript gotchas. They're very funny, and don't get me wrong, I love JavaScript. I write so much JavaScript, and I actually love even Brendan Eich, who invented it. He's a great person. But Ruby, as Matt said once to me, is a much more high-level language, and it's much more pleasurable to use. Has many more features, and that's it. That's a good reason for caring about this, and that moved me to look for this implementation. So this happens when you don't test for network. So in the broken image, there was the Nebula logo, which I thank for being here. And my name is Elia Schito, as I said, I've been working on this on the JavaScript implementation of the Ruby programming language, which is called Opal, for about 7 years, and I'm the lead maintainer for. I've been the lead maintainer for about 5 years, and I started working with Ruby in 2006. Just to say a couple of things about myself, and I have a broken image. So, what we're gonna do now is this. We're going to have a look at Opal, a couple of basic things about how it works. It basically translates Ruby code to JavaScript. It's a one-to-one translation, so methods are going to be functions, and the classes are going to be prototypes, and arrays share the same class. The same goes for function, which is mapped to procs. And there's a bunch of features like these. We have method missing, module prepend, include, inheritance, extend, singleton classes, a bunch of features. I can list them all. I will just do a quick demo with an hello world. That part is actually live coded. The rest, for your sake and my sake, it will be with different versions of a small game. It's a Tetris, a Tetris clone. We will see the same code run first on the CLI, on the terminal, and then we'll use the same engine and create a UI based on the browser. We'll do that with Vanilla DOM API, and then we'll switch, hopefully we'll have time, we'll switch to Vue.js. If we're lucky, we'll get time for questions. Too early. So let's go to the terminal first, and we're actually using the beta 1 of the 1.0 version. With hopefully I'll release soon, and the actual released version has a couple of features less, but for the sake of the demo, it's good to know what version we're using. So what's the basic hello world with Opal? We have basically all the common switches that Ruby has. It's mapped one-to-one, and we can just do this, puts hello world. Can I spell? So this is now compiling to JavaScript and then running with Node.js. We can even see the compiled JavaScript. As you see, the gist of the code is here. We have source map support and everything else. So let's have a look at the terminal version. Okay. So it's working. I can go down. Okay, it's super basic and probably buggy in some way. It's the least amount of work I could do, and this is the basically the files we will deal with. I will completely skip the game engine because it's probably uninteresting for the sake of this talk, and also very basic. So let's have a look at the terminal version, just to get the sense of the code. This is plain Ruby. It's not Opal. It's the terminal version. So we instantiate the game with a height and width, a helper to render the line, render the score, next shape. We have the colors in ANSI with ANSI sequences, and then a function to render the grid. This one will draw the whole grid, and this is the main game loop. So every 0.6 seconds, it will advance the game to the next status and render the game. That's how games work. The other important part is this thread with the input loop. So a game will always keep asking for the new status and render if there's any difference, or render anyway. And then at the same time, it will ask for new input and acquire that and use that to modify the state of the game. So we have the basics. As you see, the code is the simplest, and I didn't refactor, whatever. It's not the point of it's just to have some fun. So we have this other directory with the libopal, in which we have some files. But I wanted to show you that basically we have that's how we are using the Opal in this talk. We have a simple rack server, and the only other thing we've done is to enable arity checking, so we can have errors at runtime if we get the wrong argument inside methods. This can be disabled for production to have a faster, smaller code footprint, but there's a bunch of features like this that can be tweaked for production. And then we append these two paths to the Opal server. Those are lookup paths, and we'll get the file name from the environment. That's basically it. So let's start. Oh, it's already started. Okay. So this is basically, it starts with a playground, and let's do a hello world here as well. Hello world. Okay, we can now refresh, and boom, we see the hello world in the console, because by default all the output goes to the console. It's pretty straightforward. We can do another little experiment. Require native, and then this double dollar stays for the global object. In the browser's case, it's Windows, and we'll do document.write, and we should see that in the body. So as you see, it's really easy. It's Ruby. Of course, I know some of you, let's say, market themselves as backend only developers. Let's do a raise of hands. Who feels like he is a backend only developer? Okay, that's good. Okay, my challenge is this. The DOM is just another API. You want to use, I don't know, GraphQL or some fancy NoSQL database. There are different APIs. This is just another one. The language is still Ruby. You'll have to look up for the documentation for the DOM, but the basic tools you have are the ones you know and love. You can reuse. That was a big point for me that moved me toward this. You can reuse all of your object-oriented design skills. You can reuse all of your experience, and you have much higher level tools to do stuff. Actually, a couple of people from the Hyperstack framework, which maps React to Opal, say that when they switch the application from JavaScript to Opal, not just the code base was smaller, because of course Ruby is more concise, but also the final bundle was much smaller. And that I think it's because the Ruby core library and standard library is so great. Not many other languages have this feature, which is one of the many features of Ruby. So let's start to look at the actual game code, how it looks. Looks good. Okay. So the first thing we're requiring is Opal, of course, then the game engine, and then native, as we saw, it's a wrapper around the global object. We store the document object inside a global variable. I know that's triggering for some, because global variables should be never used. But this is one of the few good cases. As you have standard out in a global variable, that's a similar case. And the same we do here in the end, because maybe, I don't know if we'll do it, but we want to be able to access both the game and the application from the browser console. So we initialize. This is pretty basic. We can skip to the second thing. Okay. So at this point, we are sketching how we're going to, as you see, this implementation is more object-oriented. We have a class. And of course, Ruby is multi-paradigm, so we can do things in many ways, which is enjoyable to some extent. And in this case, we instantiate the application, then we do some setup, and then we start the game. The setup will take care of setting up all the event handlers, and the start will start the game ticker, the main loop of the game, which is done for those who do some JavaScript with set interval. It's all very basic stuff. So let's start doing some of the setup, and we have a document. We add an event listener for key down, and I'm happy I'm not live coding this, because I could never remember these numbers for the arrow keys, and we select the right symbol for the arrow keys, and then send a move message to the game instance. And then we call render, which in theory will be responsible for updating our game board. And okay, so then I stopped the table HTML, which will be the game board, because in perfect web development fashion, I thought the best technology to render something on the web was a table. Being a retro game, I thought it was proper. So then we start the game. We store the interval and call set interval. As you see, we're passing a lambda function. It will call tick on the game and then render every 600 milliseconds. So it's the same amount we had for the terminal. And then it's the same code that we had before. Okay, let's get to more juicy stuff. Here's the table HTML. We have some simple styling and very basic HTML. So I know it's ugly. It can be done many other ways, much better. But we're just having fun. So here we're printing a table row for each row of the game, and then a cell for the width. Very basic. So this one we already saw. So here we get to the point where we then we set up the HTML for the game, for the board. And as you see, we call the query selector. It's all vanilla DOM API with body. And then assign the property inner HTML with the table HTML. At this point, we can start to implement render. And for each row and column, we will get from the game the assigned color, and then we will memorize the cell, just not to put too much pressure on the browser. Probably it's not necessary, but and then with a CSS selector, we go to the specific cell we want. After that, if that cell has a color, then we add a class for the color, and we update the color's status, and then otherwise we remove the color class and we empty the status. Okay, I think we have, okay. So now we have most of the game ready. We have just another adjustment. We replaced a couple of new lines here with an H3, and we will update the text of the H3 with the score and with a game over if the game is over. So still very basic, and that's basically the game. The only other thing, let's go to the version 5. And see. Okay, so for some reason it's not working because it's demo time. So it will work in the number 6, in which we add some, we prepare some CSS styling for the colors. My idea was to show an all gray Tetris and then add the colors. Imagine that. Sorry. So at this point, the classes will work, and it should show. There we go. Yay. So it's very basic. It's 80 lines of code. It's fun to do this kind of stuff, and beyond fun, it's a great technology. Actually, I used it in production for many years, and the level of maintainability and cleanliness of the front-end code, I don't know how many of you have dealt with big front-end application. Okay, the level of that code was, the level of cleanliness of that code was improving with the years. So I'll say it again, front-end code, years goes by and the code improves. I think that's a great achievement for front-end code, and we were able to build a semi-in-house framework for that. That was, I think, about 50 lines of code. It was just a wrapper around some jQuery calls and selectors, very basic stuff, very powerful. So since the title was mentioning Vue.js, we'll have a final step in which we translate this vanilla DOM API and use a super simple wrapper of Vue.js I avoided building a whole complete wrapper of the library because it was too much, and I had to prepare all the rest. And also because it's fun to see how the wrapper is just 3 lines. And I'll show you in a moment. So, Vue.js version. Here we define a view method. As you see, it takes some options. I don't know who in the room knows something about Vue.js. Okay. Okay, Vue.js is fairly simple to start with. It just takes just instantiates an instance of the Vue class from JavaScript and receives an option and a JavaScript object with options. And it relies on a template that stays within the DOM as HTML. So very simple. So, and this is the whole wrapper. Okay, so as you see, this is another way we can reach to JavaScript from Opal with backticks, which of course don't make sense in a browser environment because you can't reach the system. And it was done by CoffeeScript too, so we stayed in the same vein. You can also do that with %x for those who know that syntax. And of course, we call to_n on options because I show you here. Because this thing here we are passing, what kind of object it is? What do you think? An hash. That's right. It's an hash. And what we can think simplistically is that hashes are just like JavaScript objects or JSON objects. That's not true. Hashes are way more powerful. You can set full object as keys, and they're very powerful. They have plenty of methods and capabilities. So we have to kind of downgrade this powerful object to a more simple JavaScript object with this call, which is added by the native library. And in this way, we are just passing a simple options with a data object. And the way Vue.js works is that when we update that object at JavaScript level, the rendering will happen by itself. So we just have to update the object. The rest of the stuff, the DOM stuff, the updating will be done by Vue. That's very efficient and much easier to do. So let's have a look at the render method. As you see, it's much simpler. Here is the third way we can reach for JavaScript from Opal, which is by this .js call. These calls are special at the compiler level and will be translated to either property access, in this case, or if we don't use the square brackets, but just do another dot with a method call to method calls directly to JavaScript. Those are two alternatives. You can use backticks or this syntax as you please. I think this is in line with Ruby, having many ways to do the same thing, not because we just want to have many ways to do the same thing, but because different things look better and work better and are more readable in different ways. Of course, as it's always true with Ruby, you can screw up and do the opposite, and that's up to you. With great power comes great responsibility. So we all know that, but we prefer basically quoting DHH, this kind of freedom to having to declare all the types, declare all the variables. I actually came out of, I think, 6 months of TypeScript. I thought about a bunch of things about TypeScript before starting, and what I thought afterwards was even worse, because, I'm sorry, because the type checking was easily breakable. The whole chain of type checks was easily breakable by a single point in which you didn't check. So the effort, it's not that it's not valuable, there's some value, but the effort required to add that is way more than the gain, in my view of course, than the gain you get out of it. And you probably get a false sense of security by using a type checked language, which in the end you're probably, in my experience, this is anecdotal, but many people I talk with, they just use any everywhere. So that's no really good point. And the examples you get usually are very trivial and don't work with real code. Anecdotal, it's my experience, I don't want to, but I like Ruby more. And so this is kind of an antithesis with the TypeScript C# world, as we all know. So, I don't know how much time I covered with this code and this presentation, but basically we're done with the code. I thought it was good to allow you to drive the last part of the talk with questions instead of me explaining stuff about Opal, which has a very wide range of features, and this way I will explain stuff that matters to you. And in the meantime, thank you for listening to me. And I'll ask before the question time, I want to propose you a couple of things to do. Of course, one is go to the site. It's .com because a domain squad got hold of the .org. That's unfortunate. So don't get to the wrong site. And on the site, there's a try page with a live code editor. You can try code and see the JavaScript output and see stuff without even installing. Opal can compile itself. So it's a self-hosted language, as they say, that attests to the level of to the quality level of the library. And we also use Ruby spec to test the features. We are currently passing, I think, 16,000 examples. And for those of you, that's interesting. For those of you who have raised test suites, how much you think it will take to pass 16,000 examples? Okay, in Node, it goes in under 15 seconds. Okay, so it's also very, very efficient and very fast because the translation is to the, in most cases, just one-to-one to plain JavaScript. There's, of course, some supporting libraries. The other thing I want to invite you to do is to go on the repository and watch for releases. So you can get a notification when 1.0 comes out. I think will be not too much intrusive in your email. And the code for this presentation and everything we saw, it will be at this repository. You can go there and watch it. Maybe I'll do some updates. I'm interested in proposals, issues, questions. There I think it's a way we can connect after this presentation and can continue the question time. And of course I have stickers out, which is always nice. So, anyone has any question?